Is 3. Before I find that, I need to find the corresponding y value. So when x is 3, plug in 3 to find the corresponding y value. So 2 times 3 squared plus 5 times 3 squared minus 3 plus 12. The y value is 2 times 3 cubed plus 5 times 3 squared minus 3 plus 12. I'm getting 108. Let me check that again. 2 times 3 cubed plus 5 times 3 squared minus 3 plus 12. I get 108 again. So I say 108 is right. And so first thing I need to find is f prime of x. F prime of x. So f prime of x is going to be equal to, carry down the power, 6x squared. 5x squared now, differentiate 5x squared, I get 10x. And then minus x, I differentiate that, that's minus 1. And so that's f prime of x, 6x squared plus 10x minus 1. So now what do I need? I need now f prime of 3. So f prime of 3 is equal to, put in 3, I get 6 times 3 squared plus 10 times 3 minus 1. So f prime of 3, I'm getting 83. And so the equation of the tangent now is going to be y minus yp. So it's y minus 108. It's equal to the gradient of the tangent, which is 83, into x minus xp, which is x minus 3. Into x minus 3. So if you want to finish it, you get y is equal to 83x, then minus 3 times 83 plus 108 is minus 141. Minus 141. That's why. Nice and easy, soft. Part B, it says, a function f is defined on real numbers, and it says calculate the limit from the left-hand side and the limit from the right-hand side. No. The limit from the left-hand side, you just plug in right here. So the limit as x approaches 0 from the left-hand side minus the mean from the left-hand side of f of x, that will be equal to, plugging in 0 in here, we get 0 plus 0 plus 3. And so the limit from the left-hand side is 3. All right, now it says find a limit from the right. The limit from the right is when x is greater than 0. So the limit from the right-hand side when x is positive of the function f of x. And so all we need to do is plug in now, x has 0, and I get a times 0. A times 0 plus b which is equal to b. All right. Nice. So the limit from the right is b. It says, hence determine the values of a and b such that the function is continuous. If the function is continuous, then the limit from the left is equal to the limit from the right. And so that must mean 3 is equal to b and a must be equal to 0. Nice and easy, soft. Covered. What? 5 marks? Why is this 5 marks? Let me check back again. Hence determine the values of a and b for the function to be continuous. For the function to be continuous, why is it giving 5 marks? Why they want to scare us? Something is off. If the function is continuous, then f of 0 must be defined. F of 0 is defined and f of 0 is 3. And then the limit from the left must equal to the limit from the right. Limit from the left is 3. And so that's telling us that 3 must equal to the limit from the right. And the limit from the right is a times 0. A times 0 is 0 plus b. So b must equal 3. All right? Yeah. And if b equals 3, then that must mean that a must be 0. A has to be 0. A can't be no other value. In order for it to be continuous, a must be 0. Because now you have a times x plus b, where b is 3, is equal to 3. And if a times x plus 3 is equal to 3, then a must be equal, then a times x must be 0. So a must be 0. I don't know why that is 5 marks. That's crazy. I'm not sure why this is 5 marks, but this should be b is 3 and a is 0. I'm not sure why that is 5 marks. That's crazy. It says now, if the value of b is 3, determine a such that let's go again. That's 5 marks. Something is off. Let's go again. Why is this? Determine the values of a and b for it to be continuous. Well, I'm getting that b is definitely 3 and a is 0. Well, unless they want to argue that a don't necessarily have to be 0, because x is 0 anyway. So 0 times 0 is 0. 2 times 0 is 0. 3 times, unless they want to argue a is any positive number. So I guess they could write a is 0. Or you could tell them that a is just an element of real. A can take any real number, unless you want to give them that. But I still don't see why is it 5 marks. And why would they say if the value of b is 3 when b is definitely 3? All right, let's just continue. They're just trying to throw us off with their word. Well, if b is 3, determine a such that f prime of 0 is the limit of f of 0 plus t minus f of 0 over t. So f prime of 0, I'm working with the function that is defined. I'll work with the function that's defined. So going from here, I know that f prime of x would be x squared is 2x plus 2. I'm going to work with that one. That's 2x plus 2. And when you plug in 0, You're getting that f prime of 0 is 2. I'm getting f prime of 0 is 2. Just throwing that in there, f prime of 0 is 2. So let's continue around here. F prime of 0, which I found to be 2, is going to be equal to the limit of f of 0 plus t. F of 0 plus t is going to be replace x with 0 plus t. So it's going to be the limit as t tends to 0. It's the limit as t tends to 0 of f of 0 plus t. So it's going to be f of 0 plus t. And we want to determine a. So I'm going to go in the second one, and it was ax. It's going to be a times x, and x is now 0 plus t. And that's plus 3ax plus b is now 3 minus a times 0 minus 3 divided by t. So 2 is equal to, continuing, I get a times 0 is 0 times t. So I'm getting the limit as t goes to 0 of, I plug in this now, I get at, and then 3 minus 3 cancel each other. So it's the limit of at over t. T's cancel, and so the limit of at over t is a, and so a equal to, therefore a is equal to 2. That's the answer. A is equal to 2. Okay, nice. And that's 6 marks. I don't understand why it's at 6 marks. All we did was differentiate this to get f prime of x is 2x plus 2. Plug in 0. F prime of 0 is 2. I don't see why this is so much marks, but this is the only plausible technique to evaluate A. Now it says, using first principles differentiate f of x, which is root x. Now this looks like a 6 marks question. This is fair. Now before I do this question, I always like to write down what I know I should get. I know that f prime of x should be carried on the power to give me a half. Subtract 1 from the power. I know that f prime of x should be a half x to the minus half. So that's what I'm aiming to get, a half x to the minus half, which can be written as 1 over 2 root x. That's what I should get, 1 over 2 root x. Nice. Use first principles to differentiate this. All right. Let's use first principles. So using first principles to differentiate this, what we're going to get then is f prime of x is going to be equal to the limit, is the limit as h tends to 0 of f of x plus h f of x plus h minus f of x over h. All right, and so let's do that now. Let's evaluate f prime of x. Evaluating f prime of x, what we're going to get is plugging in h as 0, plugging in x as x plus h, that will become the square root of x plus h minus the square root of x minus the square root of x, and this is all being divided by h. I forgot to write a limit, so this should be a limit. L stand for limit in this case as h approaches 0. Now, anytime you're doing these questions, once it's a square root, rationalize. So we're going to multiply by the conjugate. The conjugate is x plus h plus root x over x plus h, square root that is of x plus h plus root x so this is what we have now. And so what do we do next? Well, we go ahead and sort that out. So what we're going to get is f prime of x being the first derivative is going to be equal to, we work it out, it's going to be the limit as h tends to 0 of, working out the numerator, we're going to get root of x plus h minus root x times root of x plus h plus root x is the difference of 2 squared, which is x plus h minus x, and x plus h minus x, just leave h. If you're wondering where the h go, let me write it out. Let's not skip any steps there. It's gonna leave x plus h minus x in the numerator. In the denominator, we're gonna have h times the square root of x plus h plus the square root of x and so now we're good. We're good now. Now the x minus x becomes 0 in the numerator, and then you're just left back with h, and then this h cancels this h, and then once the h is cancelled, you can apply the limits now and plug in h as 0 in this denominator to get 1 over, applying the 0, you get, well, the square root 1 come all the way over here, so applying the 0 now, you get the square root of x plus 0 plus the square root of x, and so f prime of x is 1 over 2 root x. When you add them, you get 1 over 2 root x. And that concludes this paper. Nice and easy, soft. And this concludes 2016 paper. We're finished. All right. So I hope this really helps for those practicing 2016 paper. Make sure to just like and subscribe to the channel, and all the best prepping for your exam.